starting with functions and function notation. So this is somewhat similar to what we did last year in quadratics in Algebra 2. I purposely tried to throw in some of that vocab there so it would be slightly familiar now that you're in pre-cal. So a function describes the relationship between an independent variable and a dependent variable. In pre-cal, they use independent and dependent variables a lot more than what you're used to. It's just your x's and y's. For a relation, so a relation is just any graph. That we actually did this in Algebra 2 today. The very first lesson is deciding if something is a function or not. Everything is considered a relation. Every graph, table, set of points. But for it to have the extra name of function, the x values cannot repeat. So we learned that at the very, very beginning of x values cannot repeat. So your input value, there's a lot of words we'll use for x's and y's. Your input, those are your x values. So if I use the word input, I'm talking about x's. This is the independent variable. And from that we get our domain. So input, independent variable, x values, domain, those are all basically the same thing. And so then output values are your y, your y's. Or what variable? Dependent variable. And what do you think goes in this blank? Range. I like to think independent and input. Those go together. That's how I remember. Because I would always flip independent or dependent. Independent, input. They both start with IN. And I know input is x's. All right, and then when we're talking about the rate of change of a function, we're going to talk about this a lot. The rate of change is the slope. Now in Algebra 2, and we did probably more unit 6, we talked about increasing and decreasing, concave up and concave down. Right. So increasing, we would say that a graph is increasing here's the official definition, as the input values increase. Inputs are your what? X's. So as your X's get bigger, the outputs or the Y's get bigger. So as you move to the right of the graph, so as you move to the right, your X's are getting bigger. You got to think of this as like your number line. As your X's get bigger, your Y's get bigger. That means that is increasing. So some questions, the reason you would need to know that is because you might have a graph and it might be multiple choice, and I say, is the function increasing or decreasing here? And you would have you would have like 4 answer choices. One of them would say increasing, and then it would have this definition with it. And then your next one might also say increasing, but it would have the wrong definition with it. So those are the types of questions that you might see a lot. So you have to be able to know if it's increasing or decreasing and know the reasoning behind it. So decreasing, so as the input values increase, so still as we go to the right, as we move to the right, what's happening to the y's? They're getting smaller. So as you move from left to right, we always read left to right. So when it says as the input values increase, that just means left to right. If you want to... So if we're going from left, going towards the right, that's just what that means. Now we also talk about graphs being concave up or concave down. Do you remember the fun saying we had last year? Concave up like a cup. Concave down like a crown. There you go. So concave up is when, I mean, you can visually see when it's concave up. That's easier, I think. But the definition is what makes it harder. So concave up is when the rate of change. What's another word for the rate of change? The slope is increasing. Now let me kind of help you visualize this. This is really hard to grasp at the beginning. We talk about this every unit from here on out. So last year, it was like, I can't wrap my mind around this, but by the end, everybody was like, oh yeah, that's easy, I get it now. So there may be things that you don't get this first time around. You'll eventually, my goal is that you know it by AP test time. So if I were to take a ruler and I were to like kind of maybe draw a slope between those 2 points. Draw a line. What would you say about the slope of that line? You may know? Yep. The slope is actually not decreasing. The slope is talking about the steepness. The steepness of this line right here does not change. The slope is negative. If I were to tell you to come up with the equation of that line, y equals mx plus b, you would have a negative slope. Because your rise over run, it would go down and then over. So you start out with a negative slope. And if I did the same thing over here, what would you say about that slope? It's positive. It may be, to me it looks like it's a positive 1. But that doesn't really matter. So if you have slopes that are going from negative, if I start over here, if I kept doing this a whole bunch of times, and I just kept finding the slopes, they would start negative, and then they would become positive. So you have little lines, little slopes, from negative to positive. Numbers that go from negative to positive are increasing. So if you have a graph and I ask you, is it concave up or concave down? Visually, it's easier to see, oh, it's more like a smile, like a cup, okay? But then when it gets to the reasoning behind it, we're looking for the rate of change is increasing. And then concave down is the opposite. So if you were to draw a line on this side, and you were to draw a line on this side, you have a positive slope moving into a negative slope. So from positive to negative, if you have a positive number and you're working your way down to a negative, those numbers are getting smaller. I know it's like confusing at first because it's just a lot of words. Sometimes it's just going to be confusing for the first little bit until you practice it, until it clicks with you. And that's okay. So we're going to look at some examples. And we're going to write some intervals. Remember in Algebra 2 we did intervals. You have, it looks like an ordered pair, but it's a starting x and then it's an ending x. So this is the graph of h. And I want to find all of the intervals where h is increasing. So I'm going to take my highlighter. If I start over here, am I going to start by increasing or decreasing? Decreasing. And then I do what? Increase. When do I stop using my green? Kind of right in the middle. And then you would say after that, it starts going downhill. I get here and I see a little, like, it kind of changes a little bit. Am I still decreasing or am I increasing now? I'm still decreasing. The line is still going down. And then I get down there to the bottom. We're always going to use parentheses. There's a debate between should I use parentheses or the square brackets. You may not even remember anything about that. It's like a heated thing in calculus teachers. Like it's weird, but they fuss about it. But you will never be tested like when you write an interval. Sometimes you're supposed to put a parenthesis. Sometimes it's supposed to be a square bracket. That's never going to cost you the question. If it's multiple choice, they're all going to be like parentheses. It's not like you're going to have one answer choice that uses parentheses and one that uses the little square brackets. So don't stress too much about it. But what we're doing when we write an interval, we're going to start with a parenthesis. We're going to put the starting x, comma, the stopping x. So I have two sections here where I am increasing, because I use green for that. So what is the first x value where I start increasing? -2. And I increase all the way up here. What is that x value? 0. So that's one of the intervals of increasing. All right, what is the other one? Start at 4, ends 7. Now notice there is a closed dot there. If it had been an arrow, what would you have put? Infinity. You would have put infinity. I want you to do number 2. So I should have 2 intervals. Kaylee, what is one of those intervals? -4 to -2. Good. And Serenity, what's the other one? 0 to 4. Good. Now the next one is asking about concave up and concave down. So let's see how I can do this. Right here, this section right here, what would you say about that one? That section is concave down. I'm going to put CCD. But if you think I'm not going to know what CCD means tomorrow, write concave down. And then this would be the concave up. It's kind of I mean, when you look at that, even if this had been a more smooth line, at some point in your brain, you would naturally have switched it from concave down to concave up. Now, in pre-cal, you all don't know, and I'm not going to teach you how to figure out this exact point where it switches. That's a calculus thing. But naturally, it's usually somewhere in the middle. So it's kind of halfway between here and here. That is called the point of inflection. And for this class, for what you all know, it's going to be it's going to be kind of like a guess, not a guess, but you're going to estimate, and I would expect it to be fairly close. Like, to me, that one's 2-1. Okay, but so if you put like 2-5, no, that's not. So what I want you to do now is look at number 3. We're going to write the interval where H is concave up. So where does it start being concave up to where does it stop? Now this right here, a straight line, we don't say either or. It does not, it's not concave up or down. So it's just kind of like the curved lines. And I wouldn't ask you if that interval is concave up or down. If you want to verify with someone next to you before I call on someone. If you miss it, it's okay. All right. Addie.
Oh, gosh. 2-7.
That is correct.
Yeah.
So it starts here, and it's concave up, because this right here looks like a smile, looks like a cup. All right.
So we don't count the y at all on this.
When you're writing an interval, you don't put the y value there. Guess what? If it's multiple choice, guess what's going to be on there? Probably y's. Your tests that you all are taking, I don't write them. They are written by Brian Passwater. Most of them who is very, very, very well knowledgeable in the setup of the test. When people write real test questions, there are teachers that write test questions to AP. You have to have all of your answer choices, and you have to have a reasoning. So you have one correct answer, and then all of the ones that are wrong, you have to have a valid reason why they're wrong. So every wrong answer on there is it's not just some made up random number that you would never get. It has to be, and he writes all of his tests that way. I'm giving you everything to prepare you for the exam at the end. All right, number 4. I want the interval where H is both increasing and it's concave down. So your function can be increasing and you can have concave down. And if you just want to shut that one out, what do we think? -2 to 0. Good. So concave down is this section right here. Of this section, only part of it was increasing. And decreasing and concave up. What? So if you start at 0, this part right here is concave down. So it only switches to concave up in this section right here. So 2, 4. All right, you've got enough time to do this last question. You might want to try using a pencil because it might be that you like draw a little bit and see if it works. You might have to erase. I would not do this with a pen. So I want you to see if you can come up with a graph that fits this. I give you intervals of increasing, decreasing, concave up, concave down. So it might be some trial and error to play around with it. And then I'm going to pull some of yours to show up there. Real quick. Increasing, -4 to 1. Increasing, that is correct. 5 to 7, yes. Decreasing from 1 to 5, yes. Concave up from 3 to 6. I would say that this one is concave up from 3 to 7. Concave down, -4 to 3. This needs to be like that, and 6 to 7. So it should have went like this, but almost.